What's up, everybody? This is your boy Tech G back with another video to help you successfully pass CompTIA A+ 220-1101 certification exam. So let's get into it. In this video, you're going to learn about network troubleshooting. So most computing devices that an IT professional encounters are connected to a network. The common network issues discussed in this video are essential knowledge for an IT professional, and understanding the problems and solutions is important for the 220-1101 exam and to aid in your ongoing work. So let's talk about the first common symptom, which is no connectivity. So for no connectivity errors, you want to do the following. You want to check the power supply going to the hub, switch, wireless access point, or router. You want to simply reset the device. Next, you want to isolate the problem. So if only the users connected to a new switch that is connected to an existing switch lose their network connection, you want to check the connection between the existing switch and the new one to make sure they are plugged into similar ports. Also, most switches have an uplink port that is used to connect an additional switch, and this is the best way to establish a reliable connection. And if the uplink port appears to be connected properly, you want to check the cable. Uplink ports, they perform the crossover for the user, enabling you to use an ordinary network cable to add a hub or a switch. And as a tip, if you use a crossover cable, you must connect the new hub or switch through a regular port, not through the uplink port. Next symptom you might experience is external interference and intermittent wireless connectivity. So intermittent connectivity can be caused by the following, such as dead spots or poor signals on the wireless network. So you want to relocate the wireless router to solve that issue, or you may have too many networks using the same channel. So you want to use a wireless networking scanning device or app to see local wireless networks and their channels, then reconfigure the network to use a channel with less traffic. You might experience EMI or RFI interference with the wired network. So alarm systems, elevators, fluorescent lights, and motors, they can cause interference with networks running UTP. You want to switch to STP cabling or relocate the cables away from the interference. You may experience a defective network cable, such as a cracked outer jacket or a broken locking tab. If that's the case, you want to replace the cable, or you may have problems with the ISP's internet service. So if the problems persist after you troubleshoot the local network, you need to contact your ISP. Slow network speeds. So significant drops in network performance and slow transfer speeds can be traced to a variety of causes. The first one could be damage to cables, connectors, hubs, switches, and routers. If that's the case, you want to check the cables for damage. It could be connecting high-speed NICs to low-speed switches. So when using gigabit Ethernet switches and routers, you want to confirm that all devices on the network, such as the switches, routers, cables, and NICs, they meet the gigabit Ethernet standards, such as Cat5e, 6, 6A, or 7 cables, and they are configured to use gigabit Ethernet. Another cause could be high internet demand. So fast local connections, but sluggish internet connections can be caused by too much demand for the internet connection, perhaps due to multiple downloads or streaming services, or internet congestion outside the home or office. And another cause could be RFI EMI interference with wireless networks. So you want to check wireless phones and microwave ovens to see if their use interferes with the network. You want to move the router away from the interference sources. You want to switch to a wireless 802.11 AC router and NICs and use the 5 gigahertz band to avoid most of this type of interference. 802.11 AX, which is also known as Wi-Fi 6. This will broadcast at 2.4 gigahertz or 5 gigahertz, and when authorized by governments in the 6 gigahertz range. It is currently in beta testing, and this will become the standard over the next few years. So keep that in mind. Next symptom you might experience is limited connectivity. So a low signal on a wireless network can be caused by the following. The first one is interference from other wireless networks. If that's the case, you want to use a wireless network analyzer to determine the least used channels for the network and switch to one of those channels. It can be caused by concrete or masonry walls in the building. So if relocating the router is not possible, add another wireless access point in places that can broadcast around obstacles. Might be caused by a repeater. In residential construction, you want to consider using power line repeaters. Another problem could be improper antenna positioning on the router or NICs with adjustable antennas. If that's the case, you want to follow the manufacturer recommendations. And another issue could be a router or NIC that doesn't support multi-user, multiple input, multiple output antennas. So multiple user, multiple input, output. This enables a router to make MIMO connections to multiple users at the same time. Multi-user MIMO, it requires routers and client device support, but it can be implemented on client devices that have only one single antenna. These devices are increasingly common and the prices are going down. And with so many wireless devices in homes and businesses competing for wireless bandwidth, a multi-user MIMO solution could inexpensively double the speed of downstream traffic on a network. Next symptom is latency. So all networks experience a certain amount of data delay, and this is called latency, which is the time it takes to get a packet of data through the devices between the sender and the receiver. Latency is normal, and networks are designed to accept a certain amount of it on a consistent level. High latency, this can be caused by router overloads or high demand on a key bottleneck of a network. And network designers know that a certain amount of latency will always exist on the network, but they try to keep it as small as their network devices will allow. And network latency problems can usually be traced to a networking device, such as a router or a switch. And we have network jitter. So network jitter, this is the presence of variations of a network's latency. And jitter can cause problems for end users on the network, such as slow web page loading in browsers and faulty speech and conversations. These are some of the most noticeable problems that people experience. Also, jitter is also caused by too much demand for bandwidth, and this can be caused by too many users on a small network, such as in a crowded coffee shop or event space with many devices accessing the network, or by even a few people demanding too much data, such as an uncrowded coffee shop, but all the patrons are trying to stream videos. Either way, the network cannot process all the data. So ways to mitigate jitter can be built into the network in these ways, such as limiting the number of connections on a Wi-Fi channel, limiting the number of users on the Wi-Fi network to keep the access point from being overworked, limiting devices that require large data flows to wired connections not on the wireless network, blocking gaming and movies if this is appropriate, and putting voice traffic on a different network segment. Next symptom is poor voice over internet protocol, or VoIP quality. So VoIP traffic, this is different from most other network traffic because it must be received in the exact order it was sent to make sense. VoIP is greatly affected by excessive latency and jitter, and poor network quality means that some parts of the conversation arrive out of sequence, causing confusion and frustration. So the quality of the connection must be without jitter. Advanced network configuration, this allows for VoIP to be prioritized over other traffic. And the best way to ensure that VoIP is stable and high quality is to keep it on a separate local network from regular data. By configuring the router to prioritize VoIP, traffic voice conversations will remain reliable and clear. And the final symptom you may experience is called port flapping. So port flapping, this occurs when the physical port on a device turns on and off intermittently, usually very rapidly. Several network configuration issues cause this, and this is beyond the scope of the A+ exam. However, sometimes flapping can be a very simple problem, such as a worn or loose cable. The obvious symptom of flapping is slowed network response, as several packets of information get dropped and need to be resent. This can cause even more congestion, and sometimes the link simply appears to go down because it cannot keep up with the traffic. If this is the case, you want to change to a different switch port if possible. You want to check the cables too, because sometimes a connection fails because a cable was pulled or twisted and no longer connects properly. All right, so this was my video on network troubleshooting.